And this is interesting because this was done by Mike Burkhardt at Iowa State University. You can see that the annual average discharge has gone up, and it goes up parallel with the increase in percent annual crop coverage in the Raccoon River watershed. So you'd say, well, no brainer, right? They're cause and effect. Well, as many of you know, they're correlated, but correlation does not mean causation. This is indeed one of the reasons that we have more flooding in Iowa. I don't think anybody would dispute the fact that landscape alteration has led to more intense flooding, but it's not the only reason. Let's see, we can say increase is partially due to landscape changes, but I'm going to say we have to look a little bit further than that, and I'll get there soon. Landscape transformation has also resulted in more runoff in cities. When you have natural ground cover, you have about 10% of the water running off on average, and half of it infiltrating the soil. In today's highly developed cities, you have that flip-flopped with over half of the water running off and about 15% infiltration. But the thing is, in Iowa, this isn't that big of a deal because we just don't have that much ground covered by cities. It's a factor, something to be concerned about, but not in Iowa in a major, major way in terms of flooding. So what can we say about floods? Well, we can say in response to landscape transformation, we've had the character of floods changing greatly. Nobody disputes now that floods are faster, they're flashier, up, down, and the size, the peaks are higher. They come up higher than they used to because the water is going way up and it goes way out of the banks before it goes back down. Are floods more frequent? A lot of people would like to say that, and all we can say is that floods may be more frequent. We just don't have, we have flood records from around the 1880s or so, for some drainages, for some a lot less than that. And so we can say they may be, but we don't have enough statistical information to say that that is true. It would make sense that they're more frequent, but we don't know for sure. But landscape transformation is not the whole story. Here is Iowa City's flood record. And here's the flood of 2008, 41,000 cubic feet per second running through the Iowa City. Look over here in 1851, 70,000 cubic feet per second, a flood that was almost twice as big. That is when much of the landscape was still prairie. We also had a bigger flood in 1918, in 1881. It's natural that we had floods because floods are what rivers do. Floodplains have evolved to hold the water that cannot be held in a river's banks at certain times when the water is excessive. And the water is excessive. If you have a huge dump of water on the landscape, even the prairie couldn't hold it. And so you did have floods before we had all the prairie plowed. You can't say that landscape transformation is not the entire story, just part of it. So you have to say, well, what about Iowa's floods? What are they like? When do we flood and why? So let's take a look at this graph. A lot of these graphs are from the book Watershed Year, and they're very nicely explained by the authors, I have to say. They did a good job. And if you look at the floods in Iowa, you can see we have two flood peaks, one in early spring and one in June, a little bit less in July. This makes sense to us. This is when we've had our floods the last couple years. The same processes were in effect in both 2008 and 2010. And those processes were that in early spring you have flooding from one of two things, either rain falling on frozen ground or a rapid snowmelt. And in June you have flooding from this wave of thunderstorms that kind of comes through Iowa. Sometimes the thunderstorms get held up, kind of move very slowly across the state, and big dumps of water in early June. And what happened in 2008 and 2010, well, we had a certain pattern that was set up, and this is a pattern that we need to watch for in the future because this seems to be a trend. And so we can't say that we can prove anything about flooding and climate change or whatever, but we can say that there's a trend, which is this: snowy winter, cold snowy winter, runoff in the spring, flooding, minor flooding in the spring when the snow melts, but a cool spring so that you don't have a lot of evaporation from this runoff. The snow melts, the riverbanks rise up to their top, flood a little bit, go back down, but because of the coolness, the soil stays moist, again because you don't have a lot of evaporation. And maybe, as in 2008, the farmers couldn't get the crops in very early, meaning that you don't have any plants in the ground to pull that water out of the soil and release it through transpiration back into the atmosphere. So that when you have a big dump of water later in the spring, you have flooding. That's what's happened in Iowa across the flood record. It happened in a big way both this year and in 2008. The thing is, what do we know now that's happening? Well, we know one thing very strongly, that Iowa is changing, Iowa is getting wetter. And we have a lot of information which is statistically significant on this, and this I've gotten from the Iowa State University Climate Science Program, which is looking at all of these trends, all of these changes, and trying to make sense of them. So what do we know about Iowa getting wetter? We know that we have wetter years. We have an increase in the number of years with rainfall exceeding 40 inches. The average rainfall in Iowa is still around, the average across the state is still around about 36 inches per year. We have more and more years where it's going above 40 inches. More and more years, we have an annual precipitation which is now about 10% greater than it was in the 1940s. So if the average was 30 inches in the 1940s, the average now is 33 inches, for example. And we know that in the historical record from about the late 1800s, Cedar Rapids' annual average rainfall has increased from 28 to 37 inches per year. Definitely more precipitation than it used to be, tremendously more. We know that we have an increase in the number of days with rainfall exceeding or equaling 1.25 inches, which is a pretty heavy rainfall. You know, if you have more than 1 1/4 inches, that's a big deal. We also have a statistically significant increase of days where we have more than 4 inches of rainfall. So all of these categories are being exceeded. We know that since the 1940s, the average stream flow in Iowa, in streams across the state, has increased about 20 to 50%. We have an increasing number of high flow days in central Iowa and an increasing number of extreme flow days. And we know that the spring soil moisture is near saturation more frequently. Why is that important? That's important because when you get these big dumps then in early summer, you can't get the water entering the soil. And that the rainfall is shifting to spring and early summer over the last 30 years. Now remember, spring and early summer are the times of the year that we have flooding. So proportionally more of the year's rainfall comes during the flood season than it used to. And we know that increasing precipitation leads to proportionally more stream flow. 20% increase in precipitation, which some people predict by 2050, would lead to a 50% increase in stream flow. Why is that? Because once the soil is saturated, the water doesn't have any place to go but right down the hill into the stream. So if we're at kind of a level now where the soil can handle the water, that is going to be not enough in the future. The more rain that we get, that rain is going to go right into the streams and lead to bigger and more flooding. Here's a graph showing that we've had more wet years since 1950. Here's the total annual statewide average precipitation. 1873 was around 32 inches per year. Now it's about 34. I said it was 36. I was wrong. But you can see also that people look and say this is statistically significant, that the wet years are more common than they were in the past. Now, how does this relate to climate change? This is the question that I think is on everybody's mind. And the one fact that people have pointed to, which is, again, statistically significant, is that, here and I'll quote, one of the clearest trends in the United States observational record is an increasing frequency and intensity of heavy precipitation events. This trend is statistically significant. This was published in 2008, June 2008, right when we were getting ours. And you can see that in our part of the country, we have 31% more extreme precipitation events than we used to. Look here at New England. They've got 67% more extreme precipitation. Really a lot. Down here in the Southwest, it's only 9%. But this is happening across the country. Bigger, more extreme rainfalls. And notice also you have that coalescing right when you get the rainfall shifting to the spring. You also get an increase in extreme events, both of which kind of complement each other in terms of flooding. So this doesn't look real good. Excuse this drawing down here. I couldn't figure out how to get those arrows to disappear. But we can say what is causing heavy rainfall events. And one thing we can say about climate change is that we do know that there is more water vapor in the air over the Midwest, which is the result of, in part, of a warmer Gulf of Mexico and Caribbean. More greenhouse gases have created warmer oceans. The temperature of the ocean has risen around the world about 1 degree Fahrenheit, if I remember correctly. And that means that there's more water vapor coming off of the Gulf of Mexico. And you may know that much of our precipitation, much of our water vapor is swept up in the summer. This kind of hot, muggy weather is moisture that's being swept up from the Gulf of Mexico. So as the Gulf water vapor has increased, we've gotten more moisture over Iowa, and if you have more moisture in the air, that means you have more rainfall. We also know that there's a certain Pacific temperature pattern that now diminishes drought because of the way it's channeling the storms. But another thing we know is that across the nation, an increase in agricultural production and irrigation also leads to more moisture in the atmosphere. And that wet soils breed more rainfall, which breed more wet soils, and it just goes around. It's a self-perpetuating cycle. So, is this climate change or not? Well, in part. I mean, this increase in water vapor is certainly related to an increase in greenhouse gases in the atmosphere. But we can't say that all of the change, again, is related either to climate change or to landscape alteration. And so you say, well, what should you do? You know, I have people saying, well, you know, if we don't know about it, it doesn't exist. But what people in general say is that we don't know if it's due to climate change, but the changes that are occurring now and the patterns that we're seeing are consistent with what the models predict.